We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Friends, let us solve some more examples on eigenvalues and eigenvectors. So let us take one. Find the eigenvalues and eigenvectors of the matrix -2, 2, -3, 2, 1, -6, -1, -2, 0. So let us take this matrix as say A. So let A be this matrix, given matrix -2, 2, -3, 2, 1, -6, -1, -2 and 0. Now we know the first we need to find out the characteristic equation. And characteristic equation is, we know that is nothing but the determinant of A minus lambda I is 0. So there is also another way of finding the characteristic equation, which is lambda cube then minus S1 lambda square plus S2 lambda minus S3 and equal to 0. Now this we know S1 is nothing but the sum of the principal diagonal elements of A, which is also called as trace of A, and that is nothing but the sum of these 3 elements. So this is equal to -2 plus 1 plus 0, and so that is -1. S2 is the sum of the minors, of principal diagonal elements of A. That means minor of this -2, and that is nothing but the determinant. So we have to just hide this row and column where -2 is there. So these 4 elements we need to write, and that is 1 minus 6 -2 0 plus minor of this 1. So this row, this column, second row, that we don't need. and we need to write a determinant having these 4 elements. Okay, and so that is -2, -3, -1 and 0, plus the minor of this 0. So this third row, third column we need to hide, and these 4 elements we need to write, and then its determinant. So that is -2, 2, 2 and 1. And so this is nothing but we know how to find the 2 by 2 determinant. So this is 0 and minus product of these two, that is 12, then plus this is 0 and minus product of these two, that is 3, plus this is -2 minus product of these two, -4, and so that is equal to -12 -3 -6, and so this is -21. Now what is S3? S3 is determinant of A, and that is nothing but determinant -2, 2, -3, 2, 1, -6, -1, -2 and 0, and the value of this determinant is, we can easily evaluate, this is -2 into these 4 elements, we don't need these two, so this is 1 into 0 and -12, so that is 0 -12, then minus 2, this we need to take minus sign, and then the second column is not there, first row is not there, these are the 4 elements, 1, 2, this 3 and 4, so 2 into 0, that is 0, then minus 1 into -6, that is -6, then -3, this one, and now this third column, first row not there, and so these 4 elements are there, so this is 2 into -2, that is -4, and minus -1 into 1, -1, so minus and -1, so that is +1, and so that is equal to, this is 24 plus 12 plus 9, and so that is nothing but 45, and therefore the characteristic equation is lambda cube, then minus S1 lambda square, so minus and minus plus, this one is minus, so plus lambda square, then plus S2 lambda, and S2 is -21, so minus 21 lambda, then minus S3, so minus 45 and equal to 0. So we need to find the roots of this equation, and you apply the trial and error by just by putting 1, not satisfied, then -1, then 2, then -2, 3, -3 and so on. So try yourself some elements and you will see that you will get minus 3 as one root. So minus 3 as one root. So here the coefficient are 1, 1, minus 21, minus 45. And so here it is 0. Then we need to add these two. Then we need to multiply these two. Then add here. Then again multiply these two. Then add here. That is minus 15. Then multiply these two. And so you will get 0. So the next is lambda square minus 2 lambda minus 15 equal to 0. Minus 15, you can have minus 2 by 5 3s are 15, then minus 5 and plus 3. So lambda plus 3, lambda minus 5 equal to 0. And therefore lambda equal to 5 minus 3 minus 3. So these are the eigenvalues. Now we need to find eigenvector corresponding to each eigenvalue. So for eigenvector, this is A minus lambda I, and so this is minus 2 minus lambda, then 2 minus 3, 2, 1 minus lambda, minus 6, minus 1, minus 2, 0 minus lambda. Okay. Now for lambda equal to 5. So A minus lambda I x is 0. So A minus phi I x equal to 0. And therefore minus 2, now lambda is phi. So here we need to put phi. So minus phi, 2, minus 3, 2, 1 minus phi, minus 6, minus 1, minus 2, minus phi, x, y, z, and 0, 0, 0. So we are having, this is nothing but minus 7, this is nothing but minus 4. So we have minus 7x plus 2y minus 3z equal to 0, then 2x minus 4y minus 6z equal to 0. We may take the last one also, minus x minus 2y minus 5z equal to 0. We can consider any two equations. Say let us consider these two and we apply the Cramer's rule. So that is x over, now coefficient of y and z here. So we write this as 2 minus 3 minus 4 minus 6 equal to minus y, the coefficient of x and z. So that is minus 7, minus 3, 2, minus 6 and equal to z over coefficient of x and y. So that is minus 7, 2, 2, minus 4. And so x over, now this is easy, minus 12 and again minus 12, these two, equal to minus y over, this is 7 6 are 42, okay, and minus and minus plus 6, this is equal to z over 28 minus 4. So this is x over minus 24, y over minus 48, z over 24. And so x over, we can take 24 minus 24, so that is 1, y over 2, z over minus 1 equal to t. And therefore x is equal to x, y, z, and so this is equal to x is t, y is 2t, z is minus t, equal to 1, t into 1, 2 minus 1. And therefore eigenvector for eigenvalue phi, lambda equal to phi, is 1, 2, minus 1. Now let us find the eigenvector corresponding to lambda equal to minus 3. So eigenvector for lambda equal to minus 3. Again, a minus lambda I x is 0, 0 matrix. So this is a plus 3ix 0 matrix. And therefore this is a minus lambda I, so a plus 3i, so minus 2 plus 3 here, okay, 2 minus 3, minus 2 plus 3, then 2, then minus 3, then here 2, 1 plus 3 and minus 6. So 2, 4, minus 6. And the third one is minus 1, minus 2 and 3. And this is x, y, z and is equal to 0, 0, 0. Now see, all the three equations, this is 1. So this is x plus 2y minus 3z equal to 0. Now if I take this one, then also x plus 2y minus 3z equal to 0. If I take this, then also x plus 2y minus 3z equal to 0. So basically we are having only one equation, and that happens when the roots are repeated. So let y equal to t1 and z equal to t2, and therefore x equal to minus 2t1 plus 3t2, and therefore x is equal to x, y, z, and that is equal to minus 2t1 plus 3t2, then t1, t2, and this we can write as I can write this as minus 2t1 t1 0 plus 3t2 0 t2. So this is t1 minus 2 1 0 plus t2 3 0 1. Okay, so therefore eigenvectors for lambda equal to minus 3 are minus 2 1 0 and 3 0 1, and these two vectors are linearly independent. Okay, thank you. Let us solve one more example. Find the eigenvalues and eigenvectors of the matrix eight minus 6 2 minus 6 7 minus 4 2 minus 4 3. So let us solve this example. So let a equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Okay, so the first thing is the characteristic equation. And we know that is nothing but determinant of a minus lambda I 0. We'll also have s1 cube, lambda cube minus s1 lambda square plus s2 lambda minus s3, and that is equal to 0. Now we know what is s1. S1 is nothing but the sum of the diagonal element, or you can say it is a trace of the matrix. That is sum of the principal diagonal element. And that is 8, 7 and 3, and so it is 18. S2 is sum of minors of principal diagonal elements. And that is nothing but the minor of 8. So here we have these 4 element. So that is 7 minus 4 minus 4 3. Then plus minor of 7. So we have these 4 elements 8, 2, 2 and 3. Then plus minor of this 3. So this will nothing but these 4 elements 8 minus 6 and 7. and that is equal to, this one is 21 minus 16. Then this one is 24 minus 4. This one is 8 into 7, 56, minus 36. And so this is equal to 5 plus 20 plus 20, and so it is 45, where S3 is determinant of A, and that is 8 minus 6, 2, minus 6, 7, minus 4, 2, minus 4, 3, and so that is nothing but, now it is easy to find the determinant 8. So these 4 elements, 7 3s are 21 minus 16. Then minus and minus 6 is there, so that will be plus 6, and we have the 4 elements. This is, so this minus 6 into 3, minus 18, and minus plus 8. Then plus 2, this 2, these 4 elements. So 6 4s are 24 minus 14. And so that is equal to, this is 40, then this is minus 10 and 6, so minus 60, and this is 20, and so this is 0. So the characteristic equation is lambda cube minus s1 lambda square, and s1 is 18, so minus 18 lambda square, then plus s2 lambda, s2 is 45, so plus 45 lambda, and s3 it is 0, so this is 0, and therefore you can take lambda outside. Inside we are having lambda square minus 18 lambda plus 45, okay, and 45 you can have 45 as 15 3s are 45, minus 15 minus 3, so that is nothing but lambda minus 3 lambda minus 15 equal to 0, and therefore lambda equal to 0 3 15. You can we know the property of eigenvalues, that is if you make the product then it will be a determinant, and here we can see that it is 0, and if we add then that is nothing but the s1 trace, and that is also 18 here, so that we can see that verify our eigenvalues are correct. Now we find eigenvector for each corresponding eigenvalues. So before finding eigenvector, let us write A minus lambda I matrix. So that is nothing but 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda. So this is A minus lambda I. Now eigenvector for lambda equal to say 0. So we have A minus 0 I. and x equal to 0. Okay, so therefore that is ax equal to 0, and therefore we have 8 minus 6, then 2, then minus 6, 7, minus 4, 2, minus 4, 3, x, y, z, 0, 0, 0. And therefore this is 8x minus 6y plus 2z equal to 0, minus 6x plus 7y minus 4z equal to 0, 2x minus 4y plus 3z equal to 0. We can use any two equations in Cramer's rule. So by Cramer's rule, x over, now we take the coefficient of y and z, so that is minus 6, then 2, 7, minus 4 equal to minus y over, now we take the coefficient of x and z, so that is 8, then 2, this is minus 6 and minus 4 equal to z over, now the coefficient of x and y, so that is 8 minus 6 minus 6 7. Okay, and so this is x over, this is the 24 minus 10, so minus 14, so that is 10, then minus 32 and plus 12, so that is minus 20, and so z over 56 minus 36, so 20, and so this is x by 1 equal to y by 2 equal to z by 2 equal to t, and therefore x is equal to x, y, z, and therefore x is t, y is 2t, z is also 2t, so this is 1, 2, 2, and therefore eigenvector for eigenvalue lambda equal to 0 is 1 vector 1, 2, 2. Next we find the eigenvector for lambda equal to 3. So eigenvector for lambda equal to 3, so it is a minus 3i x equal to 0, and therefore now it is here 8 minus 3, so that is 5, 5 minus 6, 2, then minus 6, 7 minus 3, so that is 4, and minus 4, so minus 6, 4, minus 4, then 2 minus 4 and 3 minus 3, so that is 0, so 2 minus 4, 0, and x, y, z equal to 0, 0, 0. So therefore this is 5x minus 6y plus 2z equal to 0. Then can we do like this from second equation, 6, 4, 4, so we can take 2 common, so that is minus 3 x plus 2y minus 2z equal to 0. And even from third also we can take 2 outside, so we can write x minus y plus 0z equal to 0. We can use any two equation. Let us use these two. So by Cramer's rule, x over, now coefficient of y and z, so 2 minus 2 1 0 equal to minus y coefficient of x and z, minus 3 minus 2 1 0, and z over coefficient of x and y, so minus 3 2 1 minus 1. So this is x over, this is 0 and minus minus plus, so 2 minus y over again 2 equal to z over, this is a 3 minus 2, so 1 equal to, so we are having okay. So now let us just verify again. So x, so this is 2 minus 2, this is minus 1, sorry, this is minus 1 and 0. So here the coefficient is 2 minus 2, then minus 1 and 0. Okay, so that is a 0 and this is a minus 2, so this is minus 2. Okay, for y, coefficient of x minus 3 minus 2 1 and 0, so this is 0 and minus minus plus 2, so that is correct. For z, coefficient of x and y, so that is minus 3 and 2, and this is 1 minus 1, so that is correct. So this one is 3 minus 2, so that is 1. Okay, and so now we are having minus 2 1, so you can have even x by 2 equal to y by 2 equal to z by minus 1 equal to t, and therefore x equal to x y z, this is 2t minus t, and so that is nothing but 2 minus 1. Okay, so that is the eigen vector. So therefore eigenvector for lambda equal to 3 is 2 minus 1. Okay. Next, for lambda equal to 15, so a minus 15i x equal to 0. So now a minus 15, so that is a 6 minus 15, so 6 minus 15, sorry, 8 minus 15, so 8 minus 15 minus 7 minus 6 2, minus 7 minus 6 and 2, then minus 6, then 7 minus 15, so that is minus 8 minus 4. So minus 6, minus 8, minus 4. Then 2 minus 4, 3 minus 15, so minus 12. So 2 minus 4 minus 12. Okay, and therefore minus 7x minus 6y plus 2z equal to 0, minus 6x minus 8y minus 4z equal to 0. Even you can write this as 3x plus 4y plus 2z equal to 0. Then 2x minus 4y minus 12z equal to 0. That can also be written as x minus 2y minus 6z equal to 0. You can select any two equations. Let us have these two equations. So by Cramer's rule, x over now coefficient of y and z. So minus 6, 2, then y and z. So this is 4 and 2 equal to minus y coefficient of x and z. So minus 7, 2, then 3 and 2 equal to z coefficient of x and y. So minus 7, minus 6, 3 and 4. And so x, this is minus 12 minus 8. So minus 20 equal to minus y. This is a minus 14 minus 6. So minus 20 z over, this is minus 28 plus 18 minus 10 equal to t. And so this is x over minus 2 y over 2 z over minus 1 equal to t. Okay, so you may also write like this: x by 2 equal to y by minus 2 equal to z by 1 equal to t. And therefore x equal to x, y, z, that is 2t minus 2t and t. And so this is 2 minus 2 and 1. And therefore eigenvector for lambda equal to 15 is vector 2 minus 2 1. Thank you.